Hi students, good morning. Today we discuss the director circle and auxiliary circle of the ellipse. So here director circle. Director circle. Director circle means, see, this is ellipse. So these are two tangents are drawn from an external point. This point is P. If the angle between the two tangents is a right angle, that means the locus of point of intersection of perpendicular tangents of an ellipse is a circle concentric with the given ellipse. This is called director circle. This is called director circle. The locus of point of intersection of perpendicular tangents of an ellipse is also a circle concentric with the given ellipse. Concentric means having same center, 0, 0. So this is circle. This is called director circle. Tangents are drawn from this point or this point or this point or this point, provided they are at right angles. See, the locus is a circle concentric with the given ellipse is known as director circle. That is the locus of points of intersection of two perpendicular tangents. Point of intersection of perpendicular tangents of an ellipse is a circle concentric with the ellipse. Is known as director circle of the ellipse. The locus of points of intersection of perpendicular tangents of an ellipse is a circle concentric with the ellipse. It is called director circle of the ellipse. That means the two tangents are perpendicular, or you can draw tangents, the locus. This is called director circle. Next one, the equation of director circle of the ellipse. The equation of director circle of the ellipse. X square by a square plus y square by b square equal to 1 is x square plus y square is equal to a square plus b square. So this is the director circle equation. Now the point is x1 comma y1. Two tangents are drawn from an external point. If the angle is 90 degrees, this is called director circle. Now proof. Equation of tangent to the ellipse. Equation of tangent to the ellipse in slope form is y is equal to mx plus or minus root of a square m square plus b square. This is tangent equation. It passes through the point x1 comma y1 if the tangents are passes through the point x1 comma y1. So this is y1 is equal to mx1 plus or minus root of a square m square plus b square. Now take this side and squaring on both sides. y1 minus mx1 whole square equal to a square m square plus b square. So by expanding this, so this is y1 square plus m square x1 square minus 2m x1 y1 minus a square m square minus b square is equal to 0. So this is a, here you can take x1 square minus a square into m square minus this is 2x1 y1 into m plus y1 square minus b square is equal to 0. So it is a quadratic equation in terms of m, just like am square plus bm plus c equal to 0 form, which is a quadratic equation in terms of m. So for this there are two roots, means slopes. Here let m1 comma m2 are the roots. Roots means what? That is slopes. m1 comma m2 are the roots. Let m1 comma m2 are roots. Roots means slopes. What about m1 plus m2? Sum of the roots equal to minus b by a is equal to 2x1 y1 by x1 square minus a square. m1 plus m2 and m1 m2 equal to c by a. C by a means y1 square minus b square by x1 square minus a square. x1 square minus, so this is x1 square minus a square, m1 and m1 plus m2 and m1 m2. Now here, since the tangents are perpendicular, means product of slopes equal to here minus 1. Since the tangents are perpendicular, means direct circle means tangents are perpendicular. Tangents are perpendicular implies m1 m2 is equal to minus 1, where m1 is, so this is y1 square minus b square by x1 square minus a square equal to minus 1. So this implies by cross multiplication y1 square minus b square is equal to minus x1 square plus a square. So x1 square, take this side, x1 square plus y1 square is equal to a square plus b square. Therefore, the locus of the point x1 comma y1 is locus. Okay, so this is by cross multiplication, this is y1 square minus b square is equal to minus x1 square plus a square. That is x1 square plus y1 square equal to a square plus b square. Therefore, the locus of the point x1 y1 is x square plus y square equal to a square plus b square, which is a circle. Which is a circle concentric with the ellipse. but the center of the circle is 0, 0. Center of ellipse is also 0, 0. So this is called the director circle. So equation of directrix circle is x square plus y square equal to a square plus b square. Write down problem. The locus of point of intersection of two tangents to the ellipse x square by a square plus y square by b square is equal to 1, which are inclined at angles alpha and beta with major axis such that first question, cot alpha plus cot beta equal to k. Second question, tan of alpha plus beta equal to k. Third question, tan square alpha plus tan square beta equal to k is locus of point of intersection of point of intersection of two tangents to the ellipse which are inclined at angles alpha and beta with major axis, such that these three problems. The proof is the same. Here, equation of tangent to the ellipse, it passes through the point. Now we are having a quadratic equation in terms of m. m1, m2 are the roots, means slopes. First line makes an angle alpha and the second line makes an angle beta. Inclinations are alpha and beta, that means slopes are tan alpha and tan beta. That is what is m1? Tan alpha. m2 is tan beta. That is tan alpha plus tan beta is equal to 2x1 y1 by x1 square minus a square, and tan alpha into tan beta is equal to y1 square minus b square by x1 square minus a square. Okay, now we go for first problem. Cot alpha cot alpha plus cot beta equal to k. Where cot alpha is what? You write 1 by tan alpha plus 1 by tan beta equal to k. By taking LCM, this is tan alpha plus tan beta by tan alpha into tan beta equal to k. Now we have both the values are there. Now first one cot alpha means 1 by tan alpha plus 1 by tan beta is equal to k. That is tan alpha plus tan beta by tan alpha tan beta. By cross multiplication equal to k into tan alpha tan beta. Tan alpha plus tan beta equal to, so this one, 2x1 y1 by x1 square minus a square is equal to k into tan alpha into tan beta. So this is y1 square minus b square by x1 square minus a square. So these two gets cancelled. Therefore the locus is 2xy is equal to k into y square minus b square. Now second one, tan alpha plus tan beta by 1 minus tan alpha tan beta equal to k. Just a similar model, you try this sum. And also third one, tan square alpha plus tan square beta means a square plus b square. This can be written as tan alpha plus tan beta whole square minus 2 tan alpha tan beta is equal to k. Now we have the values are there, and then substituting you get the locus. Write down. Next point, if m1 comma m2 are slopes of tangents drawn from the point x1 comma y1 to the ellipse S equal to 0. S means what? Standard ellipse equation. X square by a square plus y square by b square equal to 1. And theta is angle between them. Then tan theta is equal to The formula is what? Mod of m1 minus m2 by 1 plus m1 m2. This is equal to mod of 2ab root s11 by x1 square plus y1 square minus a square minus b square. Angle between tangents. So m1 minus m2 can be written as m1 plus m2 whole square minus 4 m1 m2 under square root. Now we are having all the values. m1 minus m2 is root of m1 plus m2 whole square minus 4 m1 m2 by 1 plus m1 m2. We have m1 plus m2 and also m1 into m2. By simplifying, you get this form. 2ab into root of s11 by x1 square plus y1 square minus a square minus b square. So this is the angle between tangents to the ellipse formula. Next one, auxiliary circle. Auxiliary circle. See, this is ellipse s equal 0. So draw a tangent. This is focus S, S dash. So this is the foot of perpendicular from focus to this tangent. And also this is the foot of perpendicular from focus S dash to this tangent. Okay. The locus of feet of perpendiculars drawn from foci to any tangent lies on a circle concentric with the given ellipse. This is called auxiliary circle. Auxiliary circle. The locus of feet of perpendiculars, that means foot of perpendicular, this point. Foot of perpendicular, this point. The locus of feet of perpendiculars drawn from foci to any tangent to the ellipse lies on a circle concentric with the given ellipse is known as auxiliary circle. Okay, just write down the definition. The locus of feet of perpendiculars drawn from foci to any tangent to the ellipse. Any tangent to the ellipse lies on a circle concentric with the ellipse is called auxiliary circle. Locus of feet of perpendiculars. Locus of feet of perpendiculars drawn from focus. This is the foot of perpendicular from focus to the tangent. This is the point, is the foot of perpendicular from focus S dash to this tangent. These two lies a circle which is concentric with the ellipse is known as auxiliary circle. Or another definition is there, the circle with the major axis as diameter. The circle with the major axis of an ellipse as diameter is called auxiliary circle. But this definition is the more powerful than that, because while solving the problems we can use this definition. The equation of auxiliary circle. The equation of auxiliary circle of the ellipse x square by a square plus y square by b square equal to 1 is x square plus y square equal to a square if a is greater than b, and x square plus y square equal to b square if b is greater than a. Auxiliary circle. Now I have to derive the first one, a greater than b. So okay, now equation of tangent. Equation of tangent to this ellipse in slope form is what? Y is equal to emx plus or minus root of a square m square plus b square. Equation of tangent. Now you can call it 1. You take this side, y minus mx whole square is equal to squaring on both sides, a square m square plus b square. Let it be, this is 2. Now the equation of any line passing through foci or focus a comma 0. This is minus a comma 0 and is perpendicular to this tangent. What is slope of the tangent is what? M. What is slope of this line is minus 1 by m. So this is m slope and this slope is minus 1 by m because these two are perpendicular. So point plus or minus a comma 0, slope is minus 1 by m. So we have point and slope. So equation. Now the equation of line means what? These are the lines. Line passes through foci, that is plus or minus a comma 0 and perpendicular to 1 is. Slope of this line is what? M. Slope of this line is minus 1 by m. So y minus y1. So this is x1 by 1 is equal to m means 1 by m into x minus x1 plus or minus a, or you can take plus a or minus a. So take this side. So this is my is equal to minus x plus or minus a. Now take this side and squaring on both sides is equal to a square e square. So this is third one. Now adding 2 and 3. That is adding 2 and 3. So this is y minus mx whole square plus x plus my whole square is equal to a square m square plus b square plus a square e square. Now this is by expanding y square plus m square x square minus 2m xy plus x square plus m square y square plus 2m xy is equal to a square m square plus b square can be written as a square into 1 minus e square plus a square e square. Okay, this is 2mxy gets cancelled. B square I can write a square into 1 minus e square. Now this is here in this one you can take x square is taken common. If you take x square common, so this is m square plus 1. Okay, this and this, and these two take y square common. Y square is taken common, so this is m square plus 1. M square plus 1. So is equal to, this is a square m square plus a square minus a square e square plus a square e square. So these two gets cancelled. So this is m square plus 1 into x square plus y square is equal to, take a square common, m square plus 1. So implies x square plus y square equal to a square. So which is a circle. Which is a circle concentric with the given ellipse. So this is called auxiliary circle. This is auxiliary circle, provided if you take a greater than b case. If you take b is greater than a, then it becomes x square plus y square equal to b square. So we have good example, one problem on this definition. S 3, 4, S dash 9, 12 are the foci of an ellipse and the foot of perpendicular perpendicular from S to a ellipse, to a tangent to the ellipse. Is 1 comma minus 4. Then E is equal to eccentricity of the ellipses. Then the eccentricity of the ellipse is here 3 comma 4. So this is 3 comma 4 S dash. S dash is 9 comma 12 are the foci of ellipse, and the foot of perpendicular from S to a tangent to the ellipse is given. Consider this point is the point is P, is given 1 comma minus 4. Then the eccentricity of the ellipse is. So C is the midpoint of SS dash. C means what? Center of the ellipse. C is the midpoint of A dash. C is the midpoint of ZZ dash. C. What C is equal to? C is equal to midpoint of, means center, midpoint of S dash. Midpoint is what? X1 plus X2 by 2. That is 6. Y1 plus Y2 by 2. Y1 plus Y2 by 2. So this is 12 plus 4. 16. That is 8. Okay. Center is the midpoint. The point is P lies on where? P is the foot of perpendicular from focus to the tangent. That means the point P lies on auxiliary circle. Here, this is the point P. P lies on auxiliary circle P. So this distance is what? CP, nothing but radius of auxiliary circle. Radius of auxiliary circle. And what is SS dash is equal to distance between coordinates of foci 2AE. SS dash is equal to, that is 2AE. Distance 2AE. Distance is what? What is the SS dash? See here. This is a root of, so this is x2 minus x1, that is 36, plus this is, here it is 64, that equal to root of 100, that is equal to 10. Therefore this is 2AE is equal to 10. Implies AE is equal to 5. AE equal to 5. And this is a radius of, what is the distance between these two equal to what? Radius of auxiliary circle. Therefore CP is equal to radius of auxiliary circle. CP is what? A. A is equal to, what is the equation of auxiliary circle? X square plus y square equal to a square. Therefore A equal to a radius of auxiliary circle. So this is center is what? What is center is here 6 comma 8. So that is where C is equal to 6 comma 8 and P is equal to 1 comma minus 4. So this is root of x2 minus x1 whole square. This is equal to 25 plus y2 minus y1 whole square, 144, root of 169, that is equal to 13. Therefore A is 13, A equal to 5. Therefore eccentricity A is equal to 5, A is 13, E equal to 5, E is equal to 5 by 13. So this, if are strong in this definition, auxiliary circle definition, we have a concept, then only it is possible to solve this problem. Next one. Next one, the product of perpendiculars. Next, the product of perpendiculars from foci to any tangent to the ellipse s equal 0 is b square if a is greater than b, and a square if b greater than a. Product of perpendiculars. So there are two methods. See here. So this is, in general I am taking a greater than b. So this is x square by a square plus y square by b square equal to 1, where I am taking a greater than b. I have to explain the first one, but I go for the second one, which is very simple. Equation of tangent to the ellipse, y is equal to mx, that means mx minus y plus or minus root of a square m square plus b square. Equation of tangent. This is focus, perpendicular distance, and this is s dash, perpendicular distance. Find the length of the perpendicular from a, 0 to this tangent, and find the length of the perpendicular from minus a, 0 to this tangent. The product of these two, if you are multiplying these two, you get b square, that is one process. But I am taking very simple one, so this is too lengthy, but even though got it, any tangent to the ellipse. Now I am taking the tangent at vertex. So this is what? This is center 0, 0. This is focus a, 0. This is s dash minus a, 0. This is a 0, a, 0 at vertex. Now I can draw a tangent at vertex. What is the product of perpendiculars? SA into s dash a. Now we have to SA equal to what? SA is equal to distance a minus a. A minus a, that is a into 1 minus e. What about s dash a equal to? S dash a equal to a plus a, distance. So this is a plus a. A is taking common, 1 minus e. Now this is the perpendicular distance from focus to the tangent. This is also a perpendicular distance from second focus to the tangent. Now their product. So SA into s dash a equal to, multiplying these two, a square into 1 minus e square. So which is b square if a is greater than b. Suppose if you take b is greater than a, you get a square. Okay, so the product of perpendiculars from foci to any tangent is b square if a greater than b, and a square if b greater than a. Okay, thank you.